Attribute decision making problem. Multi-criteria decision making problem involves several objective functions within a predetermined set of constraints. Now, multi-criteria decision making problem can be categorized into two parts. One is the multi-attribute decision making problem and another one is the multi-objective decision making problem. Today, I will discuss about multi-attribute decision making problems. Multi-attribute decision making problems consider the situation which involves several objectives or attributes. Several objectives or attributes or the criteria, and these are conflicting in nature, and the process involves the selection of the alternative which is predefined alternatives, and a finite number of alternatives are available for multi-attribute decision making problem. Now, MADM, in short we are calling it as a MADM. MADM considers the criteria which are non-commensurable in nature. That means, the criteria, these are all measured in different units. That is why the process which involves a multi-attribute decision making process, it considers the normalization process, because the units are defined in different scale and we need to normalize the whole given information, and accordingly we have to take the decision. Now, multi-attribute decision making problem is generally applicable for selection or evaluation for alternatives. For example, if we are selecting a set of selecting a candidate for a job where the number of applicants are many, depending on several attributes or depending on several criteria, we are judging the suitability of the candidates and accordingly we select, or rather we rank the candidates, we are making a panel for that. In this kind of situation, multi-attribute decision making problems are very helpful, and we can apply it very easily. Since I have discussed the multi-objective MODM previously, that is why let me just define the difference between MODM and MADM. Now, I wanted to say that for MODM generally we say the objective, whereas in MADM, that is multi-attribute decision making, we are saying it is an attribute, and we are maximizing our satisfaction depending on the set of attributes given, and thus the objective of the problem. We know for the multi-objective decision making problem, the objectives are explicit in nature. These we are having the specific mathematical formulation for the objective functions, but here the multi-attribute decision making problem, the objectives are implicit in nature, but the multi-attribute decision making considers the attributes which are in explicit form, whereas in multi-objective decision making problem, the attributes, these are all implicit in nature. Now, multi-objective, we are considering the constraints may be linear, may be non-linear, which is having the specific mathematical form. That is why it can be said that in MODM, these are all the constraints are explicit, and whereas in multi-attribute, the constraints, whenever we are taking a decision, always there is a restriction. In the restricted environment we have to take the decision, but the constraints which are involved in multi-attribute decision making, the constraints are very much inherent, there is no explicit mathematical form as such, and thus the multi-attribute decision making problem is having a finite number of alternatives, that is the decision space considers the finite number of points, whereas in multi-objective we are having infinite number of decision points, the possible decisions, and thus the multi-attribute generally we are applying for selection, for evaluation kind of situation, whereas in multi-attribute decision making we are considering the design problem, where we are having some controlling parameter, and accordingly we have to take the decision that which parameter, which variable, decision variable will have which value. That is the idea for the multi-objective. Now, if I come to multi-attribute decision making problem in specific, there are several methods to solve, to tackle the multi-attribute decision making. One of the very well known methodology which has been invented in 1980, that is the analytic hierarchy process. There is another very well known method is there for multi-attribute, that is the Topsys. There is another one, that is a weaker method, and we are having outranking methods as well. That is the Prometheus. Now, today there is no scope to detail all the methods. Now, just I will start with the analytic hierarchy process, and then let us see how far we can discuss about all these methods. But one thing is that the multi-attribute decision making the methods involves decision makers perception very well, because in the process of selection of the alternative, decision makers perception is well involved in the process, and it is being taken care very seriously to take the decision. Now, coming to the analytic hierarchy process, it has been invented in 1980 by Sati, and this is the process where we are having the information regarding the alternatives, where we are having the information about the attributes as well, and in specific in AHP we are having the pairwise comparison information about the alternatives with respect to the criteria given. Now, as we know, for any decision making problem involves 4 steps. One is the collection of information, next is the quantification of information, third is the modeling, and fourth is the action, that is the optimization process in specific. Now, in the process of information acquisition, we see that the information, whatever information is available, accordingly we have to take the decision. In multi-attribute decision making problem, whatever information is available, the information may be of different kind. It may happen that the information, we are having the information regarding the alternatives, and we are having the information about the ranks of the criteria. That means which criteria is important for us, that is given to us, and which criteria is less important, that is also given. Otherwise, it may happen that the information regarding the criteria, that is not very, the information is not as such ordinal in nature, it could be cardinal in nature as well. That is why, depending on the information available regarding the criteria, we are applying the methods accordingly. In analytic hierarchy process, we are considering the pairwise preference information. Regarding the alternatives against a specific criteria. Now, if I take one example, it would be much more clearer, that is why I will explain the HP with one example. Now, this is the example. Let us consider a company is selecting a new location to expand its business. They have three locations to decide, for example, A, B and C. the company wants to use HP for this activity and considering 4 criteria for judging the locations. One, it could be property of the price, second it could be distance from suppliers, the quality of labor available in that location, and the cost of labor. These are the 4 attributes we are considering. As I said that the multi-attribute decision making problem generally considers the selection problem, and it could be applicable for selection of a place or location for future business, or it could be deciding a place to visit in a vacation, or it could be other way after doing the masters. What should be the next professional course I should select for my career? That should be another the issue where we can apply AHP. But here we are considering a specific example where a company wants to expand a business there are 3 alternatives in front of the company. One is A, one is B, and another one is C. And depending on the criteria we have to take the decision. As we could see the criteria here, now here these are non-commensurable in nature. That means these are all measured in different units, because the property of the price in rupees, distance maybe kilometer, quality of labor, that is as I said the first stage of decision making problem is the information acquisition, and next is the quantification of information. Property of the price, distance, and this could be very precisely we can quantify, but if I consider the quality of labor, this is something that is the perception of the decision maker, and the perception is here cannot be always very much precise in nature. That is why if people have worked on, this is a area of research, that is the people have worked with the fuzzy logic in HP, and there they have considered the quality of labor as a fuzzy set rather than the crisp set. But here we are not considering that fuzzy logic here. Instead of that, we are considering the quality of labor in numerical scale, that is very much precise in nature, as well as the cost of labor. Now, if this is the information for us, we have the information regarding the pairwise comparison, that is the relative weights of the alternatives, that I will give you one table for that, and this the whole table is depending on a certain scale. Let me first put the scale accordingly, and then I will just write down the given information. As I said, we are considering in HP, that is the relative importance between 2 alternatives with respect to a criteria. For example, property of price, we are having 3 alternatives with us, A, B and C. Property of price for A may be more than the property of price than B, or rather the price criteria is more important to the decision maker for location A with respect to location B. That is why if we consider the intensity of importance, how we can measure that intensity of importance? Here we are considering a scale where the scale is considering few values 1, 3, 5, 7, 9. 1 is considered for the equal importance. If both the alternatives are equally important with respect to a certain criteria, then we will put the intensity of importance 1. The 3 we will put if one is moderately important than the other objective. And the experience and judgment slightly favor one alternative instead of another alternative, and the value 5 can be referred for the strong importance. The value 7 can be given for very strong importance. That means, we are considering that alternative A is very strongly important than alternative B. Now, whatever intensity of importance measure we are considering, that totally comes out of decision makers' knowledge, decision makers' own judgment. As I said, this process is considers the decision makers' perception in each stage very seriously. That is why we are considering that decision makers perception regarding the importance of one alternative with respect to the other alternative in this way. 9 refers to the case extreme important, alright, and the other values say 2, 4, in between values 6, 8, these are all the intermediate values. That means, the compromise has to be taken. If it is 2, compromise has to be taken regarding whether it is equally important or moderately important. That is why the scale we have considered from 1 to 9. Now, we can consider the reciprocal values as well, like 1 by 3, 1 by 5. Let me start from 1 by 2, 1 by 4, 1 by 3, 1 by 4, 1 by 5, 1 by 6 up to 1 by 9. Now, it is being said that if A is moderately important than the option B, that means, if I put 3, then the other way B is 1 by 3 important than option A. In that way, we are considering the reciprocal value. In specific, we defining the reciprocal values in this way, in comparing the options, say A and B, if A, the importance of A is 3 with respect to B, then importance of B is 1 by 3 compared to A. That is why, that is the idea. All right. Now, with this information, let us have the figure with us, and we have quantified in a table in this manner. With respect to price, since we are considering A with respect to A, always the diagonal elements will be 1, and this is 3, it is given to us, this is 2, this is certainly 1 by 3, and this is given. If A, importance of A compared to C is 2, then importance of C compared to A is 1 by 2, that is the idea, and this is 5, this is 1 by 5. This is the information regarding price. If we consider the distance, these are all the decision makers perception, and we are having 1, 6, 1 by 3, these are all 1. This is the information regarding labor, quality of labor. and next is the cost of labor. This is 1, 4, 1 by 4, 2. Okay, that is the information given to us. Regarding these are all the pairwise comparisons of the alternatives with respect to a certain criteria. Since for this problem we are having 4 criteria with us, that is why we have done in this way. Now, the HP process, let me summarize first, then we will apply the process in the given problem. Now, first step of HP process is that decompose the problem into hierarchy of criteria or sub-criteria. And with respect to alternative as well, this is the most important part of this HP process, rather the MADM decision making process. And the next step normalize. As I said, whatever data we are having, these are measured in different units. That is why the normalization process is very much important. How to do the normalization I will explain. What we do, we are considering each entry divide by the column sum and take the overall row average, which will determine the ranking of priorities. Rather, it is being said as the priority vectors. If we consider the given information as a matrix, then the priority vectors gives the eigen vectors of this matrix, and we may determine the eigen value as well, and eigen value of this matrix gives you the another fact of this information for this methodology, that is called the consistency ratio, and the eigen value of the matrix gives us the idea how much this data given is trustworthy. It may happen that there is a discrepancy in the data set. In that case, the consistency ratio value is something different and that is not acceptable, then we have to revise the data set. Now, let me first say how the normalization is being done. For the normalization of the method, what we do for the price, say we are having the information regarding A, B, C, how it is being done. I am just explaining to you. The information is given 1, 3, 2, 1, 1 by 3, 1 by 5, 5, sorry, this is 1 by 2 and this is 5. What is it? It is being done, we are considering the column sum. Column sum is coming 11 by 6 here, and this is 9 and this is 16 by 5. All right. After this, we are considering the matrix in this fashion. We are considering 1 by 11 by 6, 1 by 3 by 11 by 6, 5 by 11 by 6. In this way, we are completing the whole table. This is 3 by 9, 1 by 9, 5 by 9, 2 by 16 by 5, 1 by 5 divided by 16 by 5 and 1 by 16 by 5, and this matrix will, if I consider the sum of these three, that is 6 by 11 plus 3 by 9 plus 10 by 16, and if we divide by 3, we are getting the value 0.5012. That is the priority of A we are calculating. Similarly, by considering the sum of all entries and divided by 3, this value will give you 0.1185. Again, adding all these entries of this row, dividing by 3, we will get 0.3803. If I just take the total, it will come 1.000. All right. And this is the priority vector we say. This calculates the overall priority structure with respect to price. That is why we are summarizing the information of given in the matrix, and we are saying that A is having higher priority than B and C. Rather, C is having higher priority than B. All right. In that way, we are doing the normalization process in HP. Now, the step 2, what should be the value? I will tell you in the next. Now, the next step is that step 3, we are determining the consistency ratio. And this is being calculated as consistency index divided by random index. And consistency ratio determines the all right. And with this formula we are considering, and consistency ratio Ci is being calculated as maximum eigenvalue, largest eigenvalue minus size of the matrix, that is n. Here it is 3 by 3 matrix. Always the matrix is square matrix because we are considering the pairwise comparison, and divided by size minus 1, and the random index that has been empirically studied by Professor Shetty, and accordingly it has been scaled in this way. And if we consider the size of the matrix, that is n is equal to 1, 2, 3, 4, 5, that is 2 by 2, 3 by 3, 4 by 4, 5 by 5, in this way 6. Then the random index value would be 0, 0, 0.52, 0.89, 1.11, 1.25, etc., etc. For 7 it is 1.35, for 8 it is 1.4, and accordingly we are proceeding. Now, we are considering the consistency ratio for this problem. For the previous problem, we are having the random index will come as 0.52 because the size of the matrix is 3 by 3. And if we consider the eigenvalue, that eigenvalue maximum value we will consider minus n divided by n minus 1, and accordingly consistency index will be calculated. Random index is 0.52. If we see that here, that is a consistency ratio is less than 0.1, then we conclude that the judgment, whatever judgment decision maker has given before, that is consistent enough. Now, that otherwise we can say that if the CR value is more than 0.1, then the judgments are untrustworthy. and accordingly we have to revise the data set, we have to revise the pairwise comparison information, and we have to reconstruct the matrix. That is about the judgment about the information given. And once it is over, then the next step is that is step 4 would be ratings of each alternative is multiplied by the weights of the criteria or sub criteria. For this problem, we are having 4 criteria with us. Now, one thing I should mention here also, that once we are considering the priority vector of the alternatives with respect to certain criteria, we should have information for HP another set, that is another matrix where we are having the pairwise comparison information regarding the criteria as well. And there also we have to construct the priority vector, and the ratings of alternatives means we are considering the priority vector with respect to each criteria, that has to be multiplied by the weights of the criteria, which weights can be determined from the priority vector of the given information, pairwise information given matrix. That is the comparison matrix of criteria. And once we are calculating the rating, then we have to multiply with the weights, and we have to aggregate, and we have to get the global rating, and we have to rank the alternatives accordingly. Now, for the given problem, let me just calculate the information. For the price, we have just now calculated the priority vector, that is 0.5012, 0.1185 and 0.3803. Similarly, we can do it for distance. In the similar process, we can construct the priority vector after normalization. There should be 3. Just you see, the priority vector has been calculated in such a way, always the sum is 1, here the sum is 1, here the sum is 1. And the next criteria, that is wages, we are having 0.1561, 0.6196, 0.2243. Here also if I just add all will come 1. Okay. These are the priorities of individual alternatives with respect to certain criteria. Similarly, we can have the information about the comparison matrix about the criteria as well, where we are considering price with respect to price with respect to distance, and we have again considered the scale from 1 to 9, considering 1 by 2, 1 by 3 in between as well, and here also we can consider the priority vectors in this manner. Thus, the overall weightage for the criteria can be calculated as this one. And in the next, we will consider both the informations together, this information, and in the next what we do, we are multiplying this matrix with another matrix that is having the priority vectors 0.1933, 6535, 0860 and 0612. That means, we are multiplying the priorities of each criteria with respect to the priority vector, that means multiplying with this and this row and the column. Thus, we get the values in this way. The score for A would be 0.5012 into 0.1993 plus 0.2819 into 0.6535 plus 0.1790 into 0.0860 plus 0.1561 into 0.0612 equal to 3091. This is the overall score for A. Similarly, we can have the score for B by multiplying the second row of the previous matrix with the column, that is the priority vector of the criteria. We will get the score for B is 1595 and score for C then what is the conclusion for us? We are having 3 alternatives with us. Company is having 3 alternative locations, location A, location B and location C, and with respect to the criteria, with respect to the comparison given about the preference of each the pairwise alternatives, we get the score for A is 0.3, 0.3 and 0.1. That is why certainly this is more preferable. Alternative C is more preferable with respect to the given information, and that is location C is more preferable than A than B, but location A is preferable than B, but less preferable than C. This way we can just rank the alternatives in this way. And in the next, depending on the situation, you can take the decision which one has to be selected. That is all about the AHP process. Let me come to the next way, another important process, that is the Topsys method. And the Topsys method does not consider the pairwise comparison information. It considers some other kind of information. That is why let me detail the Topsys method. In the full form of Topsys method is that technique for order preference by similarity to ideal solution. If I consider, just to see, T O P S I S, that is why in short we are calling it as Topsys method. Now, in the Topsys method we are having information this kind of, let me take one example for this. Now, we are having 3 models. Let us try to select. We want to buy some, say, electronic instrument, and we are having alternative 3 models in front of us, and depending on two criteria, we want to take a decision which model is preferable than to me. Price has been calculated in rupees, say it is 17 unit, model 2 is 10 unit and model 3 is 8 unit. But since the price of model 1 is very high, the lifespan is also very high. That is why there is a conflict in between the attributes. In one way, we want to maximize the lifespan of the electronic instrument, in otherwise we want to select the minimization of price. but if I just have this information in front of us, and very difficult to select which model is preferable to me, because if I consider the maximum lifespan, the price is very high, but if I consider the minimum price, the lifespan is very low compared to others. That is why very difficult to select. And alternatives, we are having very finite number of alternatives, only 3. That is why multi attribute decision making problem is applicable here, and we do not have any other information other than this. That is why the methodology I just explained, that is the HP is not directly applicable for this problem, because for application of HP we need the information regarding the pairwise preference structure about the models with respect to price. That means, with respect against the price, whether the model 1 is preferable than model 2 or model 1 is preferable than model 3. In that way, we are making the comparison matrix 3 by 3 matrix for both the criteria, 2 criteria we are having. That is why the HP method is not applicable here. Now, here another thing I just wanted to mention is that we are considering 2 kinds of attributes, where one we are trying to minimize the price, and another one we want to maximize the lifespan. And in Topsys method, we are naming these 2 kind of alternatives in 2 kinds of attributes in different way. We are categorizing this as the cost attribute, and this is the benefit attribute. We can have a list of cost attributes and we can have a list of benefit attributes. It is not only one, we can have 3 cost attributes, 4 benefit attributes as well, because as I said that the attributes are non-commutable in nature. That is why these are measured in different units, and for one set of attributes we are minimizing, and for another set of attributes we are maximizing. In the process of normalization means even they are in different units, we are making all in equal. That means, we are bringing all data set in a single platform. Then that is the process of normalization. There are different process of normalization. Here we are considering the vector method for this problem, and I will just explain how the normalization and the other things are being done for Topsys. Let me explain Topsys, the steps for it. Step 1. And the normalization of the decision matrix. Just now I have showed the decision matrix, and this normalization is being done with this process. Just to see, we are having a matrix x11, x12, x13, x22, x23 in that way. Rather, if I consider a multi attribute process, we are having the matrix in this fashion: x11, x12, this is the decision matrix for us. We are having m alternatives, alternative 1, alternative 2, alternative m, and we are having the criteria C1, C2, say Cn. Then we can have the matrix in this way: xn1, x n m. All right, and here few attributes could be cost attributes, few attributes could be the benefit attributes. And the normalization, the first step is that we have to take Rij as the Xij divided by summation of Xij over all I is equal to 1 to m. All right, then we will get the values for Rij all in between 0 to 1. Okay. Second step, this would be that construct the weighted matrix. How the construction is being done? From x11 the next matrix we are getting R11, R12, R1m, etc., and these are the values are all in between 0 to 1, and if we have the information regarding the weights of all attributes, then we will multiply and we will get another element for this matrix Vij. This is equal to Wj Rij, where j is running from 1 to n and I is from 1 to m. All right. That means, we are having m alternatives with respect to n criteria, and if we are having the information about the weights regarding the preference of criteria, where summation of Wj is equal to 1, j is equal to over j. If we have the information, we will reconstruct the matrix with this weighted information. After that, the next step, step 3 is that determine the ideal solution and negative ideal solution. Now, what is the meaning of it? It means that ideal solution means which is not achievable. That means, we are maximizing each objective, each criteria individually, and whatever values we are getting, that we are just making a group of it, that we are trying to achieve that value. We will say in the next that we want to minimize the distance between the decision and the ideal solution. Ideal solution is the where all the values for each objective function, these are all the maximum values, and this is certainly not within the if we just if we explain the thing with the multi objective decision making problem, we will always see the ideal solution is something which is out of the feasible space, because within the restricted environment it is not possible to get maximum satisfaction for all objectives together, because there is a trade off between the objectives, there is a trade off between the attributes. That is why at the same time we cannot maximize all the attributes together, we cannot maximize our satisfaction at the highest level for all object or for all attributes together in multi attribute decision making. But if it is so, then what is the solution for it? That is being termed as the ideal solution. That is why mathematically we can say that the ideal solution, say if I say that is A plus plus as V1 plus V2 plus Vn plus, because we are having n alternatives. Here we are considering Vj plus is equal to max O of Vij for the benefit attributes, because we want to maximize the objective function for the benefit attributes, and for the cost attributes we will consider the minimization of all. B is I have written that is the benefit attributes, and here we want is to say that j is in the cost attributes list. Then we will consider the maximum values of all, and here we are considering the minimum values for all where we are mostly satisfied. That is why in other way we can say this is the ideal solution. And similarly, we can consider the negative ideal, it is being named as the anti-ideal also, and this is being where we are not at all satisfied, which we can achieve easily, but we are not satisfied together, and this can be considered as V j minus is equal to minimization of all V I j over I, where j is the benefit attributes, and maximization where we are not satisfied at all, because we are considering the maximum value of the price. This is the cost attribute. In this way we are considering this is the ideal solution and this is the anti-ideal or the negative ideal solution. This is being named as well as the ideal solution is being named as the utopia point, also it is being named. And the next step for Topsys method is that step 4, we are considering the separation measure. How the separation measure is being done? This is j is equal to 1 to n V I j minus V j plus square. That means, we are considering the distance between the each element of the normalized matrix from the ideal point, and we are taking the square of it and we are considering the root of it. It gives us the value that the overall decision matrix, how far it is from the ideal solution. Similarly, we are calculating the separation measure to calculate the distance from the anti-ideal solution as well. V I j minus V j minus square, all right, for all I 1 to m. And the next step, step 5 is that we consider the relative closeness from the ideal solution. The measure is that S I minus divided by S I plus plus S I minus. We could see that if the elements are the ideal solution, that is V j plus, these are all V j plus, that means in other way if I can say that the matrix, if the matrix that is X I j, that the V I j is V j plus, then we are considering that we are getting C I is equal to 1. And if the elements are all the anti-ideal points, then the value would be S I, this value would be 0, clear. And in otherwise the value for C I will be in between 0 to 1. In this way, we are calculating the closeness of the decision matrix with respect to ideal solution. Okay. And once this value is we are getting in between 0 to 1, and we are trying to maximize this value as always, and the corresponding we will get the solution. All right. That is all about the Topsys method. We can apply this methodology for the given problem, and we will see the solution will come this one, that is the anti-ideal solution will come, that is the ideal solution will come 2 1 2 4, and anti-ideal will come as 1 And if we calculate the closeness values, we will see for the model 1 the relative closeness C I would be S I minus divided by S I plus S I minus, it will come as 0.2602. Model 2, the C I value will come as 0.7378, and model 3, the C I value will come 0.7398. Thus, we conclude that model 3 is more preferable than model 2 than model 3, model 1. This is the ranking, and thus we should select model 1 with the Topsys method. Now, we can conclude in this way that though I have explained the analytic hierarchy process and the Topsys method, you could realize that depending on the information given, depending on the preference structure given, we have to select the methodology, and there are some other methodologies as well, that is a weaker, Prometheus, and nowadays there is a we all develop the fuzzy multi-attribute decision making process for single expert decision making system. Even if we have a group decision making process where the opinion of the individual member of the group are different, there also how to come to the conclusion, how to make a consensus through the mathematical modeling, that is also a topic to learn. And with this I want to conclude multi-attribute decision making today. Thank you.